Alright, welcome to our Zoom classes. Thank you so much for joining. So we are now in the last class on sequences and series. Okay, and so I want to look at some questions here. Make sure before you start solving these questions, make sure you have gone through the pamphlet that I sent in the group. Okay, you need to know the formulas which are used here, when, how, and where to use them. Yeah, so it is very important. Make sure you have basic knowledge that you need under this topic. Okay, so we'll be looking at questions involving arithmetic progression and geometric progression. Okay, so make sure you have gone through those notes that I sent in the WhatsApp group. Okay, then after solving these questions, if you have any question, make sure you post in WhatsApp group, or you can just make a comment on this same YouTube channel. Okay. All right, and don't forget to subscribe. Okay, make sure you click the subscription button below. All right, so that you can enjoy more videos. Okay, let's get started. Wow. Okay, so here we are. We are on the first question here. Okay, it's here. We have the first question here. The question says, for the sequence, we have the sequence starting from -10, -7, -4, and -1. So we've been asked to find the 17th term, and B, we want to find the sum of the first 20 terms. Okay, so let's get started. So there we have our solution. All right, so we have our solutions there. So solving question A, okay, let me use black. Okay, so solving question A, we need the 17th term. So what are we going to use? So you need to know all the formulas which are used, okay, under arithmetic progression. Remember, the only way you can differentiate geometric progression from arithmetic progression is by finding the common difference, what we call the common difference. So what we are solving here, this one, is an arithmetic progression. How do we know that? So we need to find the common difference. So others will use the symbol R for the common difference, others will use the symbol D, that is to find the common difference. So that is under arithmetic progression, which is also referred to as AP. So the common difference is usually found by subtracting. If we let's say we have A2, which is the second term in the sequence, minus the first term, or it can be subtracting the third term, which we can refer to as A3, right, minus A1, I mean A2 in this case. Both will give us the common difference. Okay, so let's try it out, because this is what we're supposed to do first. If you want to find the 17th term, we need to find the common difference. So this is the formula we use to find the common difference under arithmetic progression. I just want to do it like this. Okay, let me just highlight the formula. So this is the formula, right? This one here. Okay, others will use, instead of A2 A1, others will use T2 T1. It is just still the same. Okay, so it depends on what you take. Okay, but you still get the same thing. All right, let's proceed. Let us now put everything together. So want the common difference here, so let's use R is equal to our A2. In this case, our A2 is -7, right? This is our A1, our A2, which is the second term in the sequence. So we have -7, right? Minus, we're subtracting the first term from the second term. Our first term is -10, right? Okay, so what are we getting here? So if you add and subtract, you are going to, because here negative times negative, you're getting positive, right? So we have -7 plus 10, that will give you positive 3, right? So even here, if you try, your A3 is -4, right? So if you have -4 minus A2, our A2 is -7. We just want to prove that we're going to get positive 3 as well. Here negative times negative, you are getting positive. So you have -4 plus 7, which will give you again positive 3. So 3 is your common difference, right? So our first step here will be this one, finding the common difference. Upon finding the common difference, we need to go ahead and write the nth formula. Okay, so the general nth term for arithmetic progression is given by a subscript n is equal to a, others will use a, others will use a1 to mean the first term or in your sequence. Okay, open bracket, n, which is the number or the position for the number that you want or the term that you want, minus 1 multiplied by the common difference. Okay, so again, this one is the formula for the nth term of arithmetic progression. Okay, that's this one. That is a subscript n is equal to a1 plus open bracket n minus 1 multiplied by d, which is the common difference. Okay, so we can solve for the nth term. So we want the 17th term, where so our 17th term represents our n, right? So we'll write our n, a term which is at number 17, or rather position 17 here, is equal to, so wherever we have n, we'll substitute it with 17. Our a1 is -10, that is our first term in the sequence, right? Plus open bracket, our n again is 17 minus 1, right? Our common difference is 3. So what are we getting here? So you are going to have a -10, right? Here you are having 16. Now 16 times 3, right? That is 17 minus 1. You are getting your 16 there. Now multiplying 16 times 3, you are getting 48. So you are having 48 here, right? So you are having 48. Now subtracting there, -48 plus -10 plus 48, you are getting 38 as your 17th term. So if you start looking at the values, or rather the terms in this arithmetic progression that we have, when you reach on position 17, your term will be 38, right? Okay, now we can proceed and get solve for the sum of the first 20 terms. Okay, so the sum for the first 20 terms of arithmetic progression, we'll use the formula again. What is the formula for the sum? So the formula is S subscript n is equal to n, that is the number of position or the number of those terms that we want to calculate the sum the summation, divide by 2, open bracket, 2n, okay, minus, plus, open bracket, n, that's n minus 1, close bracket, multiply by d, right? Then you close there. Okay, so we have remember our n is 20, right? So we have 20 here. So we are going to have sum of the first 20 terms is equal to n will be substituted with 20 there over 2, right? So open a bracket, we have 2 there, open bracket, we have our n, we are saying is 20, okay, and then plus, okay, we open a bracket there, and then we have n again is 20, right? Minus 1 there, multiply by d. Now a d is our common difference, which is 3, right, as you can see. So here we're going to have 10, right? We open a bracket there. Now 2 multiplied by 20, we are going to have here we've made a mistake here, so we've substituted the wrong thing. Here what we have is not n, but look at the formula. We have 2a and not 2n. This is 2a1, okay? Yes. So 2a1a implies the first term in our sequence, which is negative 10. So we have 2 negative 10, right? So we have 2 negative multiplied by negative 10, and then we proceed like that. Okay, so outside here we have 10, that is 20 divided by 2, we have 10, and then 2 multiplied by negative 10, we are going to have negative 20, right? So we have negative 20 plus 20 minus 1, and then multiplied by 3, so we are having 19 multiplied by 3, which should give you 57, right? So these are in brackets, so we are having 57. Now that 57, you are going to have 10, open bracket. Now negative 20, you are going to have negative 20 plus 57, and that will give you 37, right? So you are going to get 37 there. Then 37 multiplied by 10, that will give you, that is that's 37 multiplied by 10, which will give you 370, right? So you have 370 as the sum for your first 20 terms. Okay, all right, so that's how we calculate for arithmetic progression. We can proceed to the second question now. Unless there's any question, make sure you let me know. Okay, so the second question, which is number 2 here, we have a and b. So a states the median of 2x plus 3x and 2x plus 12 is 9, where x is a positive integer. Now we need to find the value of x. All right, so they are talking about the median here. Okay, we know how we find the median. If you have numbers, let's say 1, 5, 6, yes, like this, how do we find the median? Well, this one is arranged in, okay, let's say we have here we have 0, like this. The first thing you do is to rearrange these numbers in increasing order. So we are going to start with 0, 1, 5 and then 6, right? Yes. And what is our median? Our median, in this case, we have two numbers in between, so we add and then divide by 2, right? So the key point that we want to get is looking at what is at the middle. Okay, so that's the same concept we are going to use here. Now the terms we have this time is we have 2x, right? We have 2x plus 3, right? We have x. So as you can see, these three terms are not arranged, and here we have 2x. We have 2x plus 12. Can you see that these terms are not arranged? Let's say x is 1. Okay, let's just assume, suppose x is 1. It means the term that you are going to have here, if you substitute x with 1, you're going to have 5 here, right? Comma, if x is 1, then you're going to have 1, and this one you have 2x plus 12, which will give you 14, right? So you can see that these terms are not arranged in increasing order. So what you have to do first, what you have to do is to arrange them. So the smallest term here is x, followed by 2x, right? 2x plus 3, then followed by 2x plus 12, right? Now we've been given that the median for these terms is 9. Okay, and remember, I'm from saying the median, we look at the term in between here. Okay, so the term is an odd number. Okay, so what do? We just equate this term in between to 9 and solve for x, right? Okay, so to solve for the value of x, we are going to take this number which is at the middle of the other terms, which is 2x plus 3 is equal to 9. Okay, now solving for x, you're going to have x is equal to 6, right? Divide by this is supposed to be 2x is equal to 6, right? So dividing both sides by 2 and here by 2, you are going to use cancellation rule there, and you're going to get your x is equal to 3. Okay, so that is the value of x. Okay, all right, and you can confirm, okay, if this is the value of x. If x is 3, will the median be 9? Okay, how do we confirm that? Okay, let's replace the same number that we have, 2x plus 3, replace x with 3. So when you substitute x with 3, you're going to have 2 times 3, that's 6, 6 plus 3, and that will give you 9 as your median. All right, so let's proceed. We have the third question here. Okay, so it says for the sequence 2, 4, 8, find the common difference. So the first thing you have to do is to identify what type of sequence is it. Is it AP or GP? Okay, so how do you do that? It's by way of finding the common difference, right? So let's do this. If we say we assume this is arithmetic, is it going to satisfy the condition? If we say 4 minus 2, we are going to have 2, right? The second term minus the first term, so it will be 4 minus 2, we are going to have 2. Okay, now 8 minus 4, we are going to have 4. It means the common difference is not matching up. Okay, it's not adding up. So what are we going to do? We need to try geometric progression, because arithmetic progression is not satisfying the condition for finding the common difference. What about GP? If it's GP, which is geometric progression, then the common difference R is found by dividing the second term by the first term, or the third term divided by the second term. So suppose we have a3 divided by a2, right? So let's try this out. So our a2, if we start with this one, our a2 is 4, right? So we have 4 divided by our a1 is 2. We are saying this is equal to a3. Our a3 is 8, right? Is 8. 8 divided by 4. You see that here we are getting 2, and also here we are getting 2. So 2 is the common difference, and this satisfies the condition for geometric progression when finding the common difference. And so this sequence we are dealing with here is a geometric progression. We can go to B now and find the nth term. So the nth term for geometric progression, we use an is equal to a1, which is the first term of the sequence, multiplied by the common difference raised to the power n minus 1. Okay, so we want the nth term, which is simply the formula. So we'll substitute what we have. So we have the first term, which is 2, right? So we substitute a1 with 2 there, right? And then our r, we found r to be 2 again. Okay, now this is raised to the power n minus 1. That is, our nth term is an is equal to 2 multiplied by 2, okay, raised to the power n minus 1. Okay, so this is our nth term. We can proceed now and calculate we want the fifth term. Okay, so that is our c now. So our fifth term will be so using the same formula, this time our n, it means our n is equal to, we want the term which is on number 5, right? So our n is equal to 5. So the formula will start with a subscript 5 is equal to that is we substitute now in the formula. Okay, from this formula we are substituting. So we have 2 as our a1, we have r, which is equal to 2, that is as our r. Now this is raised to the power n minus 1, so our n is 5 minus 1, right? Now what do we get here? We are getting 2 open bracket 2 to the power what? To the power 4, right? You can now calculate that. So 2 to the power 4, what are we getting? So 2 to the power 4, that will just give you 16, right? So you are having 2 multiplied by 16, okay? And we know what we are getting there. Let me just scroll down here so that we can say the term number 5. Okay, so the term that we'll find on position 5 will be 2 multiplied by 16, which is 16 there, which will give us 32, right? Okay, so that is our fifth term. Now let's go to the last question. So this one is we'll be able to identify. Let's read the question. The question is, if the first term of a geometric progression, so this one, it should be very simple because we've been told the type of sequence that we are dealing with. This is GP. So here we are told the first term is 3, right? So the first term is 3 where the fourth term is 81. Again, to find the common difference, we use the formula for the nth term of a GP, of a geometric progression, right? So we have a subscript n is equal to our again, let's write it. We can write all of it. Okay, that is a r raised to the power n minus 1, right? So we want the common difference, right? Okay, sorry, I made a mistake here. Okay, let's do this. We have to start with a. Wanted to go direct to the nth term, so let's first find the common difference. So a is here. Okay, so a is here. So the common difference for arithmetic progression, remember, is r is equal to a2 minus a1, where substituting our a2 I want you to see something here, okay? Because someone would prefer to go direct by this formula here, okay, using this one. Now here you will note that your first term, the first term you have is 3, right? You've been told your first term to be 3 over, what is your this is our first term. Okay, our second term we do not have, right? Now our first term is 3. We are told the first term is 3, so we have a2 on top over this one here, 3. What else can we do here? There is nothing else we can do, because we do not have the value of r, which is the common difference we are looking for, and we can't use this formula for finding the common difference when we just have the first term and the fourth term, right? Unless we had the third term and the fourth term, or the first term and the second term. We could have used those two terms to find the common difference. So in this case, what we have to do is to go back to this formula. So I wanted you to see why we can't use this formula here. Okay, so we have to go back to the nth term formula and substitute what we have and leave out what we don't have. Okay, so what we have is that our a, right, our fourth term from this formula for the nth term, we are told our fourth term is 81, right? Again, our fourth term is 81, but the formula is a, right, 1 r n is 4. Here we're looking at the fourth term, right, which is that, isn't it? But remember, our a4, which is our fourth term, we've been told in the question that this is nothing but 81, right? So where we have a4, we are going to substitute with 81. So this side here, we are going to have 81 is equal to our a1, remember that is our first term, is 3, right? So you open your bracket, your r, your common difference, is what you are looking for. Okay, now on top here you are going to get to the power 3. Okay, so we need r. Now what are we going to do? First we divide through by 3, right? You use cancellation rule here, and you're going to remain with r raised to the power 3 is equal to, now 3 into 81, that will give you 27, right? Now what are you going to do here? You multiply both sides, the power by its reciprocal. That is, you're going to have 1 over 3 here multiplied by 3, right, is equal to 27 here multiplied by the power. Okay, so that will be raised to 1 over 3, right? So what are we getting? We know that here this one and this one will be cancelled using cancellation rule. Okay, so r will simply be, now this 27 raised to the power 1 over 3 can be written as finding the cube root, right? The cube root of 27, right? Now the cube root of 27 is nothing but 3, right? So our r, the common difference for this GP, is nothing but 3. Okay, that was our A now. Okay, started from here, then we shifted to this side. Okay, now we can go to B. We need the nth term. Okay, so the nth term is just the formula which you can use to find the term at any given position of the sequence that you have. So we can write our B here. Okay, so using the general formula, so the general formula, our formula is an is equal to a1, right? That's r raised to the power n minus 1. So we want the nth term, so we haven't been given the position of this term, so the position, which is n, will remain the same. Now our first term, which is a1, is nothing but 3, right? Raised to the power, our common difference. Now what is our common difference? Our common difference is we are from calculating it here, which was we found to be 3 again, right? Now this is raised to the power n minus 1. Okay, and this is the nth term. That is, this is the formula we can use to calculate any term at any given position. For example, if we want to find the first term, that means our n is going to be 1. Okay, if our n is 1, we are going to have 1 minus 1, that will give us 0, and we're going to have 3 to the power 0, which is 1, and so our first term will be 3, which is true, like what we've been told in the equation. Okay, if we say n is equal to 4, if we are going to get 81, that will be 4 minus 1, that will give you 3, and 3 raised to the power 3, that will give you 27 by 3, that will give you 81. Okay, so this is how we calculate questions involving GP and AP. Right, so thank you so much for joining into our classes today. If there is any question, make sure you post, okay, in the group. I'll be able to attend to you. Alright, thank you so much for watching. Make sure you subscribe to our YouTube channel. Alright, see you in the next video.